we're ready to rock and roll here. Alright. Alright, next problem. What is the limit as x approaches infinity to this function? Limit as approaches infinity is going to be similar to how we do horizontal asymptotes. So the numerator is actually the square root of 9x squared, which is really a 3x. Denominator is a 4x, and we don't care what the rest of that is. And it's just going to be the coefficients of those two, which in this case is 3/4, which is b. Alright. Next question. Related rates. The water is flowing into a spherical tank with a 6-foot radius. So we are given that the radius is equal to 6 feet at a constant rate. So the volume is changing over time at 30 pi cubic feet per hour. When the water is h feet deep, the volume is given by that function. They want us to find what is the rate at which the depth is changing, so that's the change in height over time. At the moment when the water is 2 feet deep, so when the height is equal to 2 feet is also given to us. Okay, so we're going to take the formula that's given, which is pi h squared over 3 times 18 minus h. Before I take the derivative of that, I'm going to distribute to simplify this a little bit. So that gives me a 6 pi h squared minus pi h cubed over 3, and that's the volume. Now when I take the derivative of this, it's going to be dv dt is equal to 12 pi h dh dt minus pi h squared dh, whoops, dt. Get rid of that there. Okay, now when we do some substitution here, this is going to be our 30 pi. H is given to us as 2, so that's going to give me a 24 pi dh dt. The 2, again using h, is going to be a 4 pi dh dt. See if I can extend this a little bit. 30 pi equals, factor out a dh dt, and this leaves me with 24 pi minus 4 pi. That's 20 pi, so we're going to have a 30 pi divided by 20 pi equals dh dt, which when we simplify is 1.5 feet per hour. Next question. Number 9, the graph of the function increasing. So we want to find the first derivative, do a first derivative number line and see where it's increasing. So the derivative is going to be equal to, that's going to be 10/3 x, subtract 3/3 from that, so that'll be to the 2/3, minus, again, another 10/3, an x minus 1/3. That's my first derivative. I want to set it equal to 0 and find my critical numbers. I'm also going to factor at the same time, factor out a 10/3 and an x to the negative 1/3. So doing my division, that gives me just an x to the first minus a 1. So now my critical numbers that I'm going to put on my number line are x equals a 0 for that value and a 1 for that value. Okay, so my f prime number line, we put 0, we put 1. We do f prime, whoops, of negative 1, f prime of a half, and f prime of 2. Okay, so first, putting negative 1 into the derivative. Now, 10/3 times x to the negative 1/3 is really 10 over 3 times the cube root of x. So let's say, if I put negative 1 in for that, the cube root is going to be negative, so that'll be a negative. Then I put -1 into there, and that's going to be a negative. Negative times a negative is a positive. It's positive, it's increasing. Okay, so I know that it's increasing less than 1. Now we'll try a half. Again, putting a half in here is going to give me a positive value. Putting a half in the parentheses here is going to give me a negative. Positive times a negative is a negative, so it's decreasing. So I know it cannot be that answer. And then f of 2, the first is going to be positive when I plug it into 10 over 3 times the cube root of x, and in the parentheses is going to give me a positive. It's positive, it's increasing, so that would make that 1. So it is increasing for 1 and 3, so that is E. Okay, number 10. Number 10, equation of the tangent line, so this is going to be a quotient rule. So the derivative is low, whoops, that is not the low one. Redo there. Low, the derivative of the top is 2, minus the top, the derivative of the bottom is 3, all over 3x minus 2, the quantity squared. You can substitute the 0.15 in at this point, or you can simplify. It doesn't really matter, because we just really want to slope it now. So I'll just plug in 1,5 for x. So when I plug in a 1 here, that's going to be 3 minus 2, which is 1 times 2. When I plug a 1 in here, that's a 5 times 3. And a 1 in here is going to be 1 squared, which is 1. So that's 2 minus 15 over 1, which is negative 13. So y minus 5 equals negative 13 times the quantity of x minus 1. Y minus 5 equals negative 13x plus 13. Move the 5 over. Y equals negative, oh, they want it in standard form, so backtrack a little bit here. Standard form will move it the other way, so it'd be 13x plus y equals 18, which is answer B. And this one was answer E. Okay, next two. Okay, the graph, this is a graph of g of x, so make sure you're aware of what graph it is. It's g of x. They want to know where the first derivative is equal to 0. So where g prime of x is equal to 0 is where the critical numbers occur. So where there's a horizontal tangent, or where it's undefined, and that's nowhere here because it's continuous everywhere. And the second derivative of x is equal to 0 is a possible point of inflection. All right, so let's go through all the points here. Point A, I need there to be a horizontal tangent, and there's not there, so it can't be A. We go to point B. Now there is a horizontal tangent at point B, but there's not a point of inflection. It does not change from concave up to concave down. Can't be B. C, there's no concavity change there, so it can't be that. And at point D, it does change from concave down to concave up, and there would be a horizontal tangent there, so it's D. And obviously it can't be E because there's no change in concavity. Okay, last one is 12. Okay, for number 12, they give us a piecewise function here. For the given function, which of the following statements must be true about f? Okay, the limit as x approaches 3 of f of x exists. And there's one or two ways that you can do this. You can kind of sketch a quick graph of this. It's a little bit tedious, but this will work. All right, so positive 2 for everything less than 3. So I'm going to go up 1, over 1, up 1, over 1, up 1, over 1. So there's the graph of that piece. And now the other one is negative 7. 1, 2, 3, 4, 5, 6, 7. Now it's going to be everything greater than that, so we're going to go up 4, 1, 2, 3, 4 over 1, up 1, 2, 3, 4 over 1, up 1, 2, 3, 4 over 1, and up 4 over 1. So it's going to go something like this. Okay, so the question asks, does the limit as x approaches 3 exist? And it does. As we approach from the left and the right, the limit would be that value there. So that is definitely going to be true. Is it continuous at 3? That's obvious by our graph. It's continuous at 3. And also you can see it's defined at 3, and there's no breaks in the graph. And another way to do continuity is you can plug in 3 into x plus 2, and you would get 5 if you plugged in 3. And if you plugged in 3, this one you'd also get 5, so if they're both equal at those values. And the one that is going to be false is differentiable, and the reason why is to the left of that point the slope is 1, and to the right of that point the slope is 4, so they do not match. So my answer is 1 and 2, which in this case is D. And again, for this last problem there's other ways to do that. That completes questions numbers 7 through 12.